We're asked to prove a formula, so we have to start with the left-hand side. There are 4 steps to proving a formula, and the first one is to pull apart the sum so that it's made up of smaller sums, and we can use the standard formulae that we've learned, the 4 standard formulae. So first of all, multiply out the brackets, you get 4r squared minus 4r plus 1, and at this point, if you've written it like that, you've gone wrong. It needs the brackets. Then we can split it apart some more, and we'll have 4 times the sum of r squared minus 4 times the sum of r plus the sum of 1. And now it's been split up into 3 sums where this one and this one and this one, they're all standard formulae that you know. So that's stage 1. And the second stage is to substitute in the formulae that we know. So the first one, sum of r squared is a sixth n plus 1, 2n plus 1, we've learned that one. Sum of r is a half n plus 1, and the sum of 1 is just n. So we can simplify that. 4 times a sixth is 2/3, and 4 times a half is 2. So that's stage 2. We've substituted in the 3 of the 4 formulae that we've learned. Now we're on to stage 3, which is the hardest one. We've got 3 separate expressions here, and we need to factorise them so that they make one expression. In order to factorise them, the hardest bit is thinking about the fractions, and the key is to look for the common denominator. We've only got one actual fraction here, and so the common denominator is clearly going to be 3. That means we've got to put everything over 3. The first one just stays the same. We've got to think what the second one's going to be. 2 is the same as 6 over 3, so that's done. And the coefficient for the last bit is 1, so that's the same as 3 over 3. And they're all over a common denominator now. I'm just going to do one more thing, which might look a little bit funny, but this is going to help us in the next stage. I'm just going to actually separate out the fraction. So a third times 2n, n plus 1, 2n plus 1. Separating out the fraction bit again, it's a third times 6n, n plus 1, and then plus a third times 3n. That'll help us when we actually do the factorisation. Now we've made the fractions look the same, we're ready to factorise. So we're looking for common factors. Well, obviously we've got a third in each bit, that's a common factor, and we've got an n in each bit, so that's another common factor. Those are the only common factors. So outside the bracket, 1/3 n. Inside the bracket, what we're left with is 2n plus 1, 2n plus 1 from the first part, minus 6n plus 1 from the second bit, and then plus 3 for the third bit. That's the end of stage 3, but we've got to check it. We've just finished stage 3, which is factorising these 3 expressions into one big expression, but before we move on, we've got to check. We need to check that 1/3 n times that equals this expression, does it? Yep. And we've got to check that 1/3 n times this expression equals this bit, including the minus sign. Yes, it does. And we've got to check that 1/3 n times 3 equals this bit. Yes, it does. So we've checked the factorising. Well, it's starting to look a little bit more like the right-hand side of the formula we're trying to prove, but we've just got to finish off now with stage 4. Stage 4 is tidying up, and that means really tidying up inside the square brackets. So we're going to multiply out n plus 1 times 2n plus 1. Well, that is 2n squared plus 3n plus 1. Minus 6 into that bracket, we've got to be really careful. A lot of students will write minus 6n plus 6, but it's minus 6n minus 6, as you know. So we'll keep going, just tidying up the square bracket. We're now going to have 4n squared plus 6n plus 2, minus 6n minus 6 plus 3. And then we'll collect together some like terms. The plus 6n and the minus 6n cancels, that's nice. And we've got 4n squared plus 2 minus 6 plus 3 is minus 1. So we're really getting somewhere. Looks really good, but we can factorise it a little bit more. We recognise 4n squared minus 1 is the difference of two squares. 2n minus 1 times 2n plus 1. And there we are. We've proved the thing that we wanted to. That's stage 4, tidying up, and the whole thing's done. So for proving a series formula, there are 4 stages we went through. The first stage was to pull it apart, and the point of doing that was that we could then use the 4 formulae that we'd learned, the 4 standard formulae. In this case, we only actually used 3 of them. The third stage was the hardest one, that was factorise. And to factorise, you've got to think about 2 things. You've got to think about the fractions, consider common denominators to get the fraction bits looking the same, and then you've got to make sure that you've pulled out every single common factor, don't leave any. For stage 4, that was just called tidying it up. That might include a little bit of factorisation at the end, like we did this time.